In a single replacement reaction, these are examples where you have redox and transfer of electrons occurs, but this is a general format for single replacement. So you could call it single replacement or also displacement, and either way, something is being replaced, something is being displaced. And so what happens is that atoms switch places. Specifically, the ones in redox are metals. So you have metal atoms that switch places. Usually you have a metal ion that forms and bonds with a non-metal to form a new product. So here's the general format that shows the reactants on the left, and you have A that represents a metal alone. So for example, just zinc or just copper. And then BC is where you have a metal plus a non-metal in an ionic compound. So B represents a metal ion in the ionic compound. Okay, so that's B. And then C is the non-metal ion in that ionic compound. Okay, so what happens in the single replacement or single displacement is that this A replaces the spot that B had and it bonds to C. Okay, so A replaces C and forms a new compound. And that new compound is the product, so it's on the right side of the reaction arrow. That's AC. Okay, now this is a new ionic compound, so this A has to form an ion first before going into this new ionic compound. Okay, so we'll look at that process. You end up with B is a new metal alone. And this is, in replacement reactions, they're actually interesting because something disappears. A disappears and B forms. And it looks like something disappears and it looks like something forms from nothing. But that's just because what you have is an element that becomes ions and you can't see. And you had ions that you can't see, and then you have an element that you can see. So we'll see examples of this. So a single replacement does not always occur. You have to use the metal activity series to predict if this is actually going to happen. And when you also have to predict when that replacement happens, that this metal alone, this element, forms an ion and then forms the ionic compound. So there are two steps in the single replacement reaction. So copper, that's Cu, and this is the ionic compound. This is silver nitrate. So using the activity series, you compare two metals. And so on that activity series, you find that copper versus, so look at copper versus silver, which is Ag. And on that activity series, you look and you find that copper is the higher metal. And so this is the higher metal, and it will replace the lower metal, which is silver. Okay, so what that means is it'll come in and it will form an ion and take over this position that silver had by bonding to this nitrate. So this is, you have to first write the ions. So let's first write the ions. And so you use the activity series first to predict, and then you have the copper forms an ion. Okay, so this ion forms and then bonds to this nitrate. So this will form an ion, +2 ion, and then bond to this nitrate. So use the crossover rule to write that chemical formula. So this would be Cu +2, and then write the nitrate ion, NO3 minus, and then use this number, crosses over and down, and you end up with the chemical formula, which is going to be Cu parentheses NO3, and then a subscript 2. There should be no plus or minus signs, and this 3 stays inside of the parentheses. The complete balanced equation, which would be Cu plus AgNO3, those are the original reactants, just copying those. And then on the other side, you end up with this product, CuNO3 2, and that's not the only thing, is you still have this silver that is the new metal that was formed. Silver that's on the product side, and this is a new element. It was an ion before, and it's a new metal that was formed. This is called a metallic deposit. Also, to have this a balanced equation, I'm going to need to put a 2 in front of this 2AgNO3, because this subscript 2, I need 2 of those nitrates. This 2 also affects the number of silvers, so I'm going to have to add a 2 here in front of this Ag. And now this is a balanced equation where you are given the reactants. You use the activity series to predict if there's going to be a replacement, and then you use the activity series to predict the ion that forms, and then write the ionic compound.